All right, guys, we are working through the second half of the review. So go ahead and pick up with me, please, on our graphs of sine and cosine. Okay, so up there at the top, it says to sketch the parent functions for sine and cosine. Remember, sine and cosine are just your waves. So let's do sine first. Sine starts at the center. And then it's going to go up to 1, back to 0, down to -1, back to 0. That's 1. Okay, then if you want to draw your second wave, you can. It does say to do 2 complete cycles. So I'll do one more. Up, middle, down, middle. Okay, like that. Oh my gosh, y'all, this fly is harassing me. Okay. Your period we just discussed is 360 degrees. That's the same as 2 pi in radians. Okay, also remember that your range, the top of the parent graph is 1 and the lowest point is -1. So remember, your domain is all real numbers because this wave goes on forever and ever and ever, but your range is -1 to 1. Okay, the only difference between the sine and cosine graphs is that sine starts at the center, cosine's already at the top when it starts. And then it goes middle, down, middle, up. There's your first one. Okay, then if you want to draw your second wave, since it says 2 complete cycles, we'll go back to middle, low, middle, high. Okay. Like I said before, our domain is all real numbers. You could also write that -infinity to infinity. Okay, so when you're taking your semester exam, if you have to, be aware those are all the same. Okay, and then your range, just like last time, is -1 to 1. Notice that we're going to give it brackets for the endpoints because my graph does hit -1 and it does hit +1. The only way we would leave those open is if those were asymptotes. Okay. All right, take a look at number 33. Okay, this one we're going to graph with some shifts and stuff in it. So let's review what happens. If you put a +10 in the parentheses, you're going to go to the left 10. That's called the phase shift. So my first reference angle is going to be to the left 10, which is -10 degrees. And then the -5 is the vertical shift. I'm going to shift us down 5. So if this is 0, I'll go 1, 2, 3, 4, 5. We'll say 5 is right here. Okay, and then remember, that's my new center line for my wave. Okay, I'm going down because of the negative. Then from there, the number in the front here tells you how tall the wave is. That's called the amplitude. So in this case, my amplitude is 7. That is a stretch because your standard wave is 1. So if 7 is bigger than 1, then remember that's a stretch. And then actually, oops, I circled in the wrong place. I should have circled here. So let's go up 7 and then down 7. Up 1, 2, 3, 4, 5, 6, 7. That would be 2. And then down 7. 1, 2, 3, 4, 5, 6, 7. That would be -12. Think about it. If this is 5, you'd go 6, 7, 8, 9, 10, 11, 12. You can just count it out. Okay, this is going to be the top. This is going to be the bottom of the wave. Then this is a sine graph. Remember, sine starts at the center. Then it goes high, middle, low, middle. That's one full wave. Okay, then if you want to draw your second one, it's the same thing. High, middle, low, middle. You can draw your second wave. Okay, but remember, it goes on like that forever and ever and ever and ever and ever. So as long as you can draw it, that's how many waves there'll be. Okay, your domain is going to be all real numbers. Your range, the low point is -12, the high point is 2. Notice we're giving inclusive brackets because we do hit 12 and -12 and 2 over and over and over again. The only way those would be open is if they were asymptotes and we could never really get. Okay, then for your horizontal stretching compression, okay, this is the number that would be between the parentheses that changes the period. Okay, so in this case, I'm gonna put no change to the period because you can see in the equation, there's not that number that's like in between the parentheses. Okay, so your period is still 360. Okay. And then you can ignore the steps there, okay? But it'd be every 360 degrees, this wave is going to repeat itself, okay? All right, go ahead and turn the page when you're ready. We'll do one more like that. Okay, remember that your sine graph starts at the center. Cosine, the only difference is you're going to start at the top. So your wave is kind of like shifted back a little bit, but overall, same process. Okay, so we're going to do number 35. Okay, first thing that I noticed is I have a -6 in parentheses. That means I'm really going to go to the right 6. So this is going to be a 6 here. Okay, the +2, I'm going to shift up to. And then it does say radians here, but on your exam, it's in degrees. So I'm going to just change that so we don't have to worry about it. So up 2. So I went over to +6 and up 2. Then from there, remember the number in the very front tells you your amplitude. Okay, so in this case, it's a 3. That's a stretch by a factor of 3. So if I'm already at 2, this is my center. Then up 1, 2, 3. This is 2, so that'd be 4, 2, 3, 4, 5. And then I'll go down 1, 2, 3. That would put me in negative. Okay, then this is a cosine graph. Remember, cosine starts at the crest at the top of the wave. So I'm going to start at 5, and then I'll go middle, low, middle, high. Okay, then I can do a second one if I want to. Start at the top. You'd go middle, low, middle, high. Okay. And then remember, it just does that same wave forever and ever and ever. Okay, for your horizontal stretch or compression, this time we have 1. Okay, look at the number in the middle here. It's a 2. Okay, if they put a ×2 though, remember, I'm going to do the reverse effect on the period. So if my normal period is 360 and they put a ×2, then I'm going to do 360 divided by 2, which means my period is going to be 1. Okay, and then remember, if you make the period longer, it's a stretch. Shorter is a compression. So if it went from 360 down to 180, that's a compression. Also, remember, if they put a ×2, I'm going to think about in my head, that's really the opposite. So instead of a stretch, it's a compression. Okay, your domain is all real numbers. Your range is from -1 to 5. And then you don't have to worry about the steps. Okay. Also remember that you can graph these in the calculator, but if you're going to graph these, I would recommend doing it in radian mode, just because the graph is going to look a little bit better. Okay, so x -6 plus 2. Okay, so this is it in degree mode. Okay, you can barely see any of the graph. Do you see that? Okay, but if I switch my mode here, if I switch it to radian, now look at how much better the graph looks. And you can even see, oh, look, it goes to 5, it goes down to -1. You can see that the wave repeats itself over and over again. So if you're gonna graph a sine or a cosine in the calculator, okay, go ahead and do it in radian, okay? All right, go ahead and take a look. We're almost done. So we have a little bit of proofs. Let's do number 36. We'll actually do both of these since I know these are kind of hard. So first thing you're gonna do, you see parentheses, well then let's distribute. So 1 times 1 is 1. 1 times minus cosine is negative cosine. Okay, then I'm going to move to the cosine and times that, and plus cosine x times 1 is a plus 1 cosine x. And then cosine times negative cosine is negative cosine squared x. Okay, remember our goal is to show that this is equal to sine squared. Okay, that's my goal. So next step, I notice that I have a minus cosine and a plus cosine. So I know that those can cross out. So then all I have left is 1 minus cosine squared x. And then again, we want to show equal to sine squared. Okay, from here, you had a rule that you learned at one point. I'm going to put it up here at the top. That sine squared plus cosine squared equals 1. So then I'm going to let 1 be replaced with the sine squared plus cosine squared here. So it's sine squared x plus cosine squared x. Okay, but then behind that, remember, that's all my 1. I had a minus cosine squared. And now hopefully you can see where this is headed. Okay, I switched the 1 into a sine squared plus cosine squared. And then I'm like, oh, well, would you look at that? Now I have a positive cosine and a minus. Those can cross out. Okay, remember for a proof, your left and right hand sides should be equal by the end of it. Check. Okay, so take a look at that, see if that makes sense. And let's go on to 37. Okay, for number 37, I'm going to replace these with their IDs. So I see that cotan x is going to be cosine over sine. Tan will be sine over cosine. Hey, what's up? You did email? Yeah. Okay. Grab a sticky off my desk and just write down check. That was great. And then I'll do it as soon as I'm done recording this. Okay. So cotan is going to be cosine over sine. And then tan is going to be sine over cosine. Okay, so remember, those are called the ratio IDs. Remember, those are called the ratio IDs. You should have those in your notes. But if you can't find them or whatever, then you'll have a formula chart when you take your exam. Bye, see you tomorrow. Huh? Oh, okay. Then from there, we have 2 fractions. The bottoms don't match. Well, then we need to fix it. So this one has a sine. This one has a cosine. Well, then I'll put a cosine here and here. And I'll put a sine here and here. And now I can see both of them have a cosine and a sine. Then I can combine into one big fraction. So it'll be a cosine and a sine on the bottom. But remember, your bottoms have to match for you to be able to add those fractions. Cosine times cosine is cosine squared x. Sine times sine is sine squared x. And then this same property that we did up here at the top, remember, sine squared plus cosine squared, that can be replaced with 1. So then from there, sine squared and cosine squared is going to be a 1 over, let's actually, so that's 1 over cosine x sine x. And then remember, 1 is the same as 1 times 1. And then from there, I can do a 1 over cosine and a 1 over sine. So 1 over cosine x is going to turn into cosecant x. And then 1 over sine is going to turn into, oops, I actually put that back. 1 over sine is secant and 1 over cosine. And then let's go through and write it your right-hand side. So all along from the beginning, I wanted this to equal cosecant secant. Cosecant secant. Cosecant secant. And then for my last one, notice that these are already in the right order. So I can just remember do that little arrow trick that I showed y'all if you don't want to write it over and over again. Check. Huh? Okay, that's fine. I'll finish. I'll do it as soon as I'm done with this. All right, now we are on your last unit, which is circles. Okay, so remember all 3 of these, you just have one of each type. So if it starts off in standard form, you're just going to have to complete the square to get it into your graphing form. So I have an x squared minus 4x, but you're blank. Okay, then I have a y squared plus 6y, then you're blank. Okay, then on the other side, my plus 1, I'm going to switch that over to be a negative 1. Then at that point, complete the square. You're going to take what you have, cut it in half. So if it's an x squared minus 4x, we're going to change the minus 4 to an x minus 2. 2 squared is a plus 4, and then I have to plus 4 over here. Remember, it doesn't matter if this is plus or minus, because negative 2 times negative 2 is still a positive. Same thing over here, it's a 6y, cut that in half, that's a 3 now. And then 3 squared for me to fill in the blank, that's a 9, and then a 9. And then from there, remember, you're just adding these 3 numbers up. So negative 1 plus 4 plus 9 gives me 12. Okay. Then from there, I can find my center. Okay, the center is going to be 2, negative 3. Remember, it's always the opposite of what you started with. So 2, negative 3 is here. And then for my radius, it's always the square root of the number on the other side. So for example, if it's a 12, usually that would be a perfect square. Okay, but unfortunately this time it's not. So our radius is going to be 3.5-ish. Okay, our radius is the square root of 12, which isn't perfect, but it's 3.5. And so then when you do your circle, okay, I'll kind of zoom in on this, but what I'm going to do when I count is I'm just going to go 3.5 boxes each direction since it didn't come out to be perfect. So 1, 2, 3.5. 1, 2, 3.5. 1, 2, 3.5. 1, 2, 3. And then just start your circle. Okay. Just like that. Okay, but on your exam, I'll make sure that this is a nice, easy whole number that you can square root easily for when you're finding your radius. All right, so we did a circle. Okay, go ahead and turn to the next page and let's go on to an ellipse. Okay, your ellipse, I have a 25x squared plus y squared minus 50x. Remember, you're just going to group these by their letters. So 25x squared minus 50x. But you're blank. Okay, then I have a y squared that's alone, and then I have an equal 0 on the other side. Then look for your GCF. Both of these can divide by 25. We'll write that here, GCF of 25. So then the 25 comes to the front. Well, then now my x squared is alone. And then 50 divided by 25 is a 2x. Okay, but then remember, if it was a negative 50 divided by 25, that's actually a minus 2x. From there, I'm going to cut this in half. So -2 cut in half is going to be a -1. And then 1 squared is a +1. But then remember, I don't add a 1 across. I have to multiply with the 25 first and then add that across over here. So remember, you GCF first, then you cut in half. Fill in the blank with your perfect square. So 1 squared is 1, but then times by 25 before you add it. Okay. Now notice your y squared is already kind of chilling by itself, so just leave it. Okay, then equals 0 plus 25 is 25. Okay, then I did make one mistake here. Remember, when you times this 1 by the 25, that's when I would say like, oh yeah, we can put that there so I don't forget. Okay, then for your ellipse, your final equation is supposed to be equal to a 1. Right now it's equal to a 25. So the way that I fix that is I just divide by 25 all the way across. So 25 divided by 25 is going to cross out here. That's just going to give me a 1. So x minus 1 squared over 1. Y squared is over 25. And then 25 divided by 25 equals 1. Okay, then from there, I can do my center, do my x and y radiuses, blah, 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 blah. So let's write our center. Our center is going to be 1, 0. Okay, think about if that makes sense. My -1 turns to a +1. My y squared is alone. So 1, 0 is here. Then remember, the square root of the number under x tells you how many to go to the side. So if it's a 1, the square root of that is 1 again. And then the square root of the number under y, that tells you how much to go up and down. So the square root of 25 is 5, then I'll go up 5, and then I'll go down 5. Okay, remember that you should also know how to identify the major and minor axes. Okay, your major axis is the longer one. So in this case, my major is vertical. Let's write that here. Major axis is vertical, equal to 5. And your minor axis is horizontal, and it was only 1. Okay. And remember, you determine whether it's major or minor based on which of the numbers is longer. Okay. All right, you have 2 hyperbolas. We're going to do the second one. Remember, the only difference from an ellipse to a hyperbola is that your GCF for ellipses are both positive, versus for a hyperbola, one of them could be negative. So let's take a look at number 41. Okay, for my y's, I notice those come first. I have a 9y squared minus a 36y. 9y squared minus 36y blank. Okay, then after that, I have a minus 4x squared minus 40x. And I said that wrong, it's a plus 40x, then you're blank. Okay, and then I have a negative 100 that I need to slide across to the other side. So when I move it across, now it's a positive 100. Then from there, I'm looking for my GCF. For my y's, my GCF is a 9. Remember, it's always the number in the front. Okay, it's always the number in the front. So my 9 comes out to the front. Now my y squared is alone. 36 divided by 9, that's now a 4y. Okay, then after I take out the GCF, I cut this in half. Half of -4 is y minus 2. 2 squared is a plus 4, but then I don't add a 4 across. I do 4 times 9, so I'm adding a 36. Okay, and then remember, when I times that 9, that's when I would go back and write that in so you don't forget it. Okay, now let's do our x's. We have a GCF. We have a -4 in the front that we need to take out. So my x squared is alone now, but then 40 divided by -4 gives me a -10x. Then remember, you take that GCF out and then you cut this in half. So half of negative 10 is x minus 5. 5 squared is 25. And then 25 times negative 4 would be a minus 100 over here. And then remember, when I times to that negative 4 in the front, I'm going to write it down here so that I don't forget about it. Okay, then from there, we're adding all three of these numbers up. 100 minus 100, and then plus 36. So we can see that's 36. Okay, but then from there, remember, it can't equal 36. If it's an ellipse, it has to equal 1. So then you would just divide that 36 across. (36) divided by 9, that's going to be a 4 on the bottom. So y minus 2 squared over 4. 36 divided by 4, my next term is going to be a 9 on the bottom. Now, some of y'all on your test were wanting to make this a negative 9. Remember, the negative's here in the middle. Okay, the minus is here. So 36 divided by negative 4 is a minus 9, and then equals 1. Okay, one thing that is tricky about ellipses is that if the y comes first in the equation, I still have to write my center in the correct order. So for this, my center is going to be positive 5, positive 2. Okay, and remember, the reason why is that if y comes first, I'm going to make my parabolas up and down for the hyperbola. Okay, but my center still has to go x then y. So 5, 2 is here. And then I'm going to take my square roots from my x and my y box. My x box is going to be the square root of the number under x, which is a 3. And then my y box is the square root of the number under y, which is a 4. So my y box, the square root of that is 2. And then remember, you're going to go 1, 2, 3, up 2, down 2. 1, 2, 3, up 2, down 2. Once you get to there, draw your box. Once you draw your box, draw your diagonals. Okay, remember that those are called slant asymptotes. And then your parabola can either go on the sides or it can go top and bottom. Okay, and remember the difference of where you put it is which letter came first. So in this case, I can see that my y came first. That means that it's going to open top and bottom. So I'm going to draw it here. Remember, it should touch your box, but it shouldn't go inside. And then it should touch the box and then go away. Okay, then I'm going to put parabolas are top, bottom, because y came first in the equation. Okay. So our parabolas are up here and down here because of where, because the y came first in the equation. Okay. Also, I think a lot of y'all noticed on your test, or at least it seemed like it, you cannot type these into your calculator. And the reason why is because they have x's and y's. Okay, so you will have to know how to use that, or how to use those equations. Okay. All right, so your job is just to finish that up. Let's get it done. And if you need any help, let me know.